공간이 넓으니까 뭔가 시적으로 나가시죠. 좀 나가주시면 감사하겠습니다. 네, 안녕하세요. 저는 미디어 이번에 운영부하던 최혜정이라고 반갑습니다. 제가 이런 거 와서 사실이 처음이라서 장소가 되게 바뀌고 익숙한 점이 좀 많았던 것 같은데 양해 부탁드리고요. 그리고 우선 이렇게 좋은 장소를 제공해주신 코리안 측에 감사드리고 이런 자리를 이렇게 해준 도미닉한테 감사드립니다. 저는 이제 코인원 블록스의 담당자분이신 위지훈님께 마이크를 넘겨드리겠습니다.
네, 안녕하세요. 코인원 블록스의 플러스 오피서인 유지훈이라고 합니다. 제가 사실 지금 코인원 블록스 오픈한 지 한 2주차 되거든요. 그리고 사실 IOTA가 저희 제공에서 행사하는 첫 번째 이제 대상이 돼서 되게 영광이고 여기 와서 되게 반갑습니다. 그래서 한 가지 말씀드릴 거는 이제 저희가 이 행사를 이렇게 한다고 해서 이제 저희 쪽 코인원에参加를 한다는 걸 이제 말씀드린 건 아니고요. 저희가 이제 장소를 제공해서 행사를 진행한다는 것만 확인해 주셨으면 좋겠고 같이 자리를 빌려주셨으면 좋겠습니다. 네, 감사합니다.
Hello everyone, so thanks a lot for coming and thanks for Coinone for hosting this. So the way that I'm going to do this presentation is that I'll just talk a bit about IOTA, where we come from, how IOTA works, a little bit technical, and most importantly I will focus on other use cases and where we're heading with IOTA. And so the way that we're going to do this is I'll speak a bit in English and then we're going to do the translations in real time.
네, 오늘 프레젠테이션은요, 이제 어떻게 IOTA가 진짜 어떻게 성장했는가, 그리고 이걸 기술적인 내용 팔고 그리고 적용 사례를 찾았습니다.
Okay, cool. So one thing about us, so we are truly awesome blockchain pioneers. So we've been in this blockchain space since 2010, 2011. And so, for example, in 2013, we invented the first full proof-of-stake blockchain, which is called NXT. And I personally have helped build the crypto valley Meetup, which is now kind of the ICO mecca around. And so back in 2015, we realized that, hey, any blockchain architecture that is out there today is simple, scalable, it has transaction fee issues, and you cannot run this in that complex environment. And so with this deep technological knowledge and this business background that we have, that we're very entrepreneurial, we came together, the four founders of IOTA, which is me, David Simsula, Sergey Lancheko, and Sergey Popov, to completely reinvent the service that is all together.
네, 저희가 일단은 저희 상당히 오랫동안 이 블록체인 생태계에서 운영하고 있었으니까 그래서 2010년도에 시작을 하고 이제 2013년도 됐으면 저희가 첫 번째 이제 완전한 지분 증명인 NXT에 관련했고요. 그리고 저 같은 경우는 개인적으로 지금 크립토밸리로 유명한 스위스 중부에서 지금은 ICO를 유명하죠. 거기서 이제 시작을 했고 저희가 2015년이 됐을 때는 현재 제가 블록체인 생태계를 봤을 때 블록체인은 확장성 문제나 아니면 수수료의 문제나 아니면 이것이 과연 IoT에 적용될 수 있을까 이런 문제들을 많이 봐서 저희가 기존에 가지고 있었던 깊은 기술적인 지식과 그리고 저희의 역시 비즈니스 노하우와 저희의 약간 창업하고 싶은 그런 마음을 합쳐서 저를 포함한 3명 더 이제 공동 창세자들이 이걸 DNT를 완전히 새로 재발견하는 그런 계기를 갖게 된 게 IOTA입니다.
And you're good. Yeah. And so basically what we invented is a tangle. And so if you look at all the innovations that happened in this space so far, everything was based on blockchain. But the overarching term is obviously distributed, that is, so blockchains are here, and Tangle and banks are here. So we are the first ones that truly went beyond blockchain. And we always joke about that IOTA is a blockchain without the blockchain without the chain. So it's really not a blockchain.
네, 그리고 저희가 이제 기존에 암호화폐 시장에 있는 모든 기술들은 다 블록체인에 기반을 하고 있고 오픈소스 기반을 하고 있습니다. 네, 저희는 이제 태그이고 태그는 대그이라는데요. 그렇게 해서 저희가 최초로 블록체인을 초월한 그런 기술을 가지고 있다고 말씀드릴 수 있고요. 그래서 저희가 농담삼아서 하는 말이 저희는 블록이 없는 그리고 체인이 없는 블록체인이라고 자주 말을 하고 있습니다.
So the way that IOTA looks like is kind of like this threaded mesh. So blockchains are a sequential chain, block after block after block, and it's obviously very limited. And so for us, the next obvious step from the sequential chain is a directed asymmetric graph. So what you see here is those blocks are a single transaction. So one transaction references two transactions in the history, and as such is kind of an attestation. So this transaction says that, hey, those two transactions are valid. In addition to that, you also say that, hey, all of the history is also valid. And through that, you kind of get this compounding security of the entire system. As more and more transactions get added, the security of transactions in the history increases up to a point where it can no longer be reversed.
네, 그래서 저희가 결국에는 저희는 대그를 사용합니다. 그래서 여기 보시는 바와 같이 일단 저 블록 하나하나가 트랜잭션 하나라고 거래 하나라고 보시면 되고요. 이제 거래 하나가 이제 다른 두 거래 행사표가 가는 것을 보실 수 있을 겁니다. 그래서 이걸 통해서 저희는 저희가 검증을 하고 또 한편으로는 이제 이 거래 기록 자체를 저희가 검증을 할 수 있습니다. 그래서 블록체인 같은 경우는 기존에는 시작 부분부터 끝 부분까지 이렇게 쭉 하나로 연결이 돼서 순차적으로 된다면 저희는 그런 방법을 생각하고 오히려 대그를 하고 되겠습니다.
So the major two differences between IOTA and the blockchain are two things. For one, we're no longer a blockchain. We're just directed asymmetric graph. And the second major difference is also like how do we achieve consensus? So the beauty of IOTA is that we no longer have any miners. Because you probably know miners are kind of the gatekeepers of the blockchain. They're there to keep the consensus. And oftentimes they can go broke, like what is happening in Bitcoin right now. And the way that consensus is achieved in IOTA is that every network participant that issues a transaction validates transactions. And as such, it's a very democratizing system where you no longer say like there are different network participants. So every network participant has the same rights. And every network participant really contributes towards the security and the consensus of the system.
네, 그래서 IOTA 블록체인의 가장 큰 차이점은 두 개라고 할 수 있는데 첫 번째는 저희가 더 이상 블록체인을 사용하지 않고 대그를 사용하는 거. 그 다음에는 합의의 걸 진행하는 겁니다. 이거는 저희는 채무자가 없습니다. 그래서 기존에 비트코인을 봤을 때 비트코인 문제는 채무자들이 굉장히 많은 힘을 행사하게 돼서 문지기 역할을 하는데 저희 같은 경우는 오히려 네트워크에 참여하는 모든 사람들이 트랜잭션을 이슈를 하고 그리고 트랜잭션을 동시에 검증을 합니다. 그래서 저희는 이것이 진짜 좀 많이 민주적인 모델이라고 생각을 하고요. 그리고 여기에 참여하는 모든 사람들은 또 그만큼 권리를 행사할 수 있습니다.
So the main features of IOTA are two things. One, you can do machine-to-machine payments, which is the obvious reason why we invented IOTA, so that one machine can pay another machine. And secondly, what you can do is you can secure data. So you know this concept of data integrity. So once you input data into a blockchain or into IOTA, it is tamper-proof. So it can never be faked again. And through that, you can build up some very, very interesting security applications. And the very unique thing about IOTA is that it's the first distributed ledger protocol that you can use to encode a token. So if you secure data in IOTA, it's completely free. In Ethereum and in Bitcoin, you also have to pay huge transaction fees.
네, 그리고 IOT의 특징이 두 가지를 말씀드리자면 첫 번째는 이제 기계 대 기계에 대한 end-to-end 계층입니다. 그래서 이게 첫 번째고 두 번째는 데이터 보안인데요. 저희가 데이터를 보안하는 것은 데이터를 이제 누군가가 들어와서 데이터를 조작할 수 없도록 만들고 그리고 이걸 통해서 매우 흥미로운 그런 보안 어플리케이션들을 여러분이 만드실 수 있습니다. 저희는 또 추가적으로 이제 그러니까 분산 원장 프로토콜 중에서는 처음으로 토큰이 없습니다. 그렇기 때문에 이더리움이나 비트코인이나 모든 것은 거래 비용을 수수료를 내야 되는데 저희가 수수료가 없습니다.
So this slide will be a bit more technical because the main question in any blockchain or in any distributed ledger is like when do you reach transaction finality? And when is a transaction as secure that it can no longer be reversed with negligible probability?
네, 저희 이제 합의 알고리즘에 대해서 말씀을 드릴 텐데요. 항상 합의 트랜잭션이 어느 시점이 됐을 때 저희가 트랜잭션을 이제 뒤로 돌릴 수 없는가, 그리고 저희가 이 트랜잭션이 맞다는 것을 저희가 정말로 굉장히 높은 확률로 저희가 검증을 해서 확진을 할 수 있을 때를 얘기합니다.
So in a blockchain, you reach transaction finality heuristic that says that, hey, after 6 blocks, your transaction is secure and it can no longer be reversed. So it's a very static kind of rule in blockchains. And in IOTA, it's much more fluid. So in IOTA, the security and the transaction finality really depends on the activity of the network. And so when it comes to determining whether a transaction is completely confirmed or not, you can look at this graph here. By the way, we told the people from the community to just look at this graph here and just paint it. Using the community, right? And so basically what you see here is 3 types of transactions. The gray transactions are tips, so they are unconfirmed transactions. The red transactions are transactions which have received some confirmation, so some references, but they're not yet fully confirmed. And the green transactions are kind of a global state in IOTA. So they are really the transactions which can no longer be reversed, and they have the highest security in the system.
Excuse me, my question. And if you have no P, some hacker is produce the infinite transaction. Is possible?
We have no key.
Infinite transaction on your network. Because there's no P.
There's a database.
Or like DDoS. DDoS. Just like DDoS.
But why could a DDoS do anything here? So we have a peer-to-peer network. It's still a peer-to-peer network.
But hacker is produce the infinite transaction on our network.
No, I think so. If you can write down the attack, but I don't think that there is any problem here. Because with the nature problem blockchains, for example, like hit attacks and stuff like that, so we circumvent that by not having key discovery. But that's something else. I'll just explain this now. Or should you just say?
일단 그러니까 기존의 비트코인 경우는 저희가 6블록을 일단 찾아야지만 비트코인 거래가 확정이 된다고 저희가 볼 수 있었는데 이 같은 경우는 너무나도 이제 유연성이 없습니다. 그래서 저희는 훨씬 더 유연한 방법으로 합의를 도출을 하고요. 저희가 합의를 도출하는 방법은 네트워크 타임라인에 따라서 정해집니다. 그래서 여기 그래프를 한번 보시면 여기에서 그래프에서 회색으로는 아직 언컨펌드 정확 확인되지 않은 그런 트랜잭션이고, 그 다음에 빨간색 같은 경우는 이제 두 명 이상에서 막 이제 자기들 피어트리어 두 명이서 이제 검증을 해준 상태입니다. 그리고 최종적으로 저기 초록색으로 보이는 거는 저거는 이제 글로벌 스테이트와 비슷하다고 보시면 됩니다. 그래서 현재 네트워크 상태이고, 그리고 이런 트랜잭션들은 다시 뒤돌릴 수 없다고 이해하시면 됩니다.
So the question is like, how do you determine if a transaction is red or green? So what they then do is, let's say that I'm a merchant and someone just issued a transaction and sent me some IOTAs. So this is the transaction. So what I as a merchant do now is I start listening on the network. So I see all of these transactions here. And after 10 seconds, for example, I execute this transaction algorithm. So what I'm doing there is I select a number of transactions here, and from these transactions I then check if there's a path to my transaction. So it can be an indirect or direct path. So if you take 4 transactions, we look at here, we go down the path and we say, okay, there's no path to my transaction. As such, this transaction is not attesting, it's not contributing towards the security of mine. But if you look at this one, and this one is a direct path. And as such, those 2 transactions are confirming it. This one is off. So we executed the transaction algorithm 4 times, we got 4 transactions, 3 out of those 4 transactions attested and they contributed towards the security of my transaction. But this one didn't do it. As such, my transaction is not yet fully confirmed. And in order to determine if a transaction is green, you execute the transaction algorithm, for example, 100 times and you say, hey, all of those tips here, they have a direct or indirect path to my transaction. As such, it reached the global state of the entire peer-to-peer network and is secure.
네, 그래서 여기서 보시면 일단 빨간색하고 초록색 이제 트랜잭션들이 무슨 차이를 가지고 있냐면 제가 상인이라고 했을 때 이제 10초 간격으로 저희가 팁 셀렉션 알고리즘을 저희가 실행시킵니다. 그러면 이제 제가 알고 싶은 것은 제가 지금 가지고 있는 트랜잭션에 직접적이나 아니면 간접적으로 이거를 검증해 줄 수 있는 그런 이제 길이 있는가, 기존에 있던 트랜잭션들이 있는가를 제가 확인하는 겁니다. 그래서 예를 들어서 제가 팁설러지 알고리즘을 이제 4번을 돌리고 난 뒤에 거기서 예를 들어서 3번 정도가 3번 정도 검증이 되는데 4번째는 아니다. 그러면 아직 그건 완전하게 이제 검증이 된 게 아니고요. 그래서 초록색 같은 경우는 이거를 이제 대략 100번 정도는 100번 정도 했을 때 꾸준히 이게 검증이 된다면 저희가 이 트랜잭션 같은 경우는 이제 네트워크의 글로벌 상태를 나타내고 있다고 저희가 확인할 수 있습니다.
That's really good if you translate in real time. Because that's the most complicated part about IOTA, and most people really get confused about what does the block say when you know the transactions are done or not. So if you understand this part about IOTA, you really get the gist of it. And you start to understand how powerful it is. Because what's really interesting is that if there is more transactions happening, the confirmation times of my transactions get much lower. It can be a few seconds even. It really depends on the activity of the network.
네, 그래서 이게 이제 IOTA의 핵심인데요. 트랜잭션이 점점도 많고 네트워크상의 활동량이 더 많다면 제가 보낸 트랜잭션이 검증되는 시간 자체도 매우 많이 줄어듭니다.
So why are we really cool? So what is the major benefits of IOTA? There's no transaction fees. So we don't have to subsidize any miners, and everyone that does a transaction contributes towards the security. As such, if you issue a transaction IOTA, you don't have to pay anyone. So if I send 1 cent, your other party receives 1 cent. And it's incredibly interesting for any application developer, any business that runs on top of IOTA, because at the end of the day, you want to have these metrics. You want to know that, hey, if I'm going to receive money, is my financial transaction actually benefiting my business model or not?
네, 그래서 일단 저희가 IOTA가 굉장히 좋은 이유 중에 하나가 일단 수수료가 없습니다. 그래서 저희 IOTA에서 트랜잭션을 보내는 사람들은 또한 이 모든 사람들이 보안에 자기들이 기여를 해야 됩니다. 이것은 시사하는 바가 큰데요. 특별히 어플 개발자들이나 아니면 비즈니스 같은 경우는 내가 일단은 1센트를 보냈을 때 다른 사람들이 1센트를 받는다는 걸 알고 싶고 이제 비즈니스 모델적인 측면에서 이 IOTA를 사용했을 때 이것이 저에게 더 효율적인 비즈니스 모델을 제공해 줄 것이라는 걸 확신을 가질 수 있게 됩니다.
And the main reason why we developed IOTA is also because of the scalability issue. So the beauty of IOTA is that the larger the network gets, the faster transactions get confirmed, and we're able to achieve much higher transaction throughput. So we always say that IOTA scales horizontally. So the more network participants are, the better it scales. And with blockchain is also completely the opposite, where the more network participants we have, the more transactions we execute. The blocks that form as such a number of unconfirmed transactions which starts rising.
네, 그리고 두 번째는 확장성에 관련된 건데요. 저희는 네트워크가 커지면 커질수록 이제 네트워크의 버틀렉이 점점 더 작아지는 그런 상황이 일어나고요. 그리고 그래서 저희는 IOTA는 확장하는 게 수평적으로 확장한다고 말합니다. 이것은 기존의 블록체인이 보여주는 양상과는 완전히 다르고 기존 블록체인은 네트워크가 커지면 커질수록 확인되지 않은 트랜잭션이 점점 기하급수적으로 늘어납니다.
Can I explain? I want to make more express because I might not understand the chart you explained just before the logic of it. But could you please more detail about how?
Yes.
Yeah. How can you solve the scalability problem?
Yeah. So blockchains serialize and confirms that each transaction after transaction gets confirmed. In IOTA it's parallelized. What this means is that transactions get confirmed at the same time. Because there's other network participants doing the validation. It's not only cycles like in blockchain. In blockchain, every Bitcoin, every 10 minutes the miners confirm transaction. Such as serialized. In IOTA it's parallelized and it's asynchronous in that regard. And the beauty of this system is that it's eventually consistent. That means that every node in the network has those green transactions, but not every node in the network has those red transactions. As such, if there's a high transaction throughput environment, a certain cluster emerges, and they have those transactions. And then after some time period, with the network propagation, everyone is going to have the same transactions. And as such, IOTA is partition covered in that regard, and is able to really adapt to those network environments.
네, 일단 이제 여기서 있어서 좀 설명드리자면 우리가 블록체인 같은 경우는 일단 지결로 연결이 되고요. 그다음에 IOTA 같은 경우는 이제 병렬로 되겠습니다. 이게 무슨 말이냐면 블록체인은 비트코인 기준으로 했을 때 10분에 한 번씩 이제 사이클을 10분에 한 번씩 저희가 블록이 생성이 됐을 때 그걸 통해서 저희가 이게 검증이 된다는 걸 알 수 있고 이제 IOTA 같은 경우는 트랜잭션이 다양한 게 있는데 여기에 참여하는 모든 참여자가 동시다발적으로 서로의 트랜잭션들을 검증을 해주고 있습니다. 그래서 결국에는 이게 컨시스턴시를 위해서 결국에는 이제 컨시스턴한 그런 스테이트를 보이게 되고요. 그리고 저희 초록색이나 빨간색이 일단은 네트워크 상태에 따라서 약간씩 다르겠지만 저희가 이걸 한번 분포를 해봤을 때 초록색이 저기 겹치는 경우가 생길 겁니다. 그렇게 해서 저희가 네트워크의 상태를 저희가 어느 정도 저희가 알 수 있습니다.
Yes, so IOTA the mainnet went live in 2016, July 2016, and since then we've transferred some $5 billion with IOTA, also without any financial intermediaries, without any transaction fees, and IOTA still has improved work.
네, IOTA가 이제 2015년 7월달에 저희가 네트워크가 런칭이고요. 그때부터 지금까지 저희가 50억 불을 저희가 일단 거래를 했습니다. 그리고 이 거래들은 일일이 다 수수료가 없었습니다. 그래서 일단은 2015년부터 지금까지 수수료 없이 네트워크가 잘 돌아가고 있습니다.
So one of the very unique things about IOTA is that we are not this foundation like everyone else. We are the first ones to serve a non-profit foundation in Germany. If you want to learn some German, it's called Gemeinnützige Stiftung. Pretty much a tongue twister, right? And so our focus with IOTA is really to develop and standardize distributed ledger protocols. So we started out with IOTA and we have a range of other protocols and softwares which we are currently developing. And the IOTA Foundation also acts as this central point where corporates, governments, and startups can come together to further push the ecosystem and participate.
네, 일단 IOTA 재단에서 말씀드리자면 IOTA 재단은 다른 재단들과 달리 스위스에 기반을 두고 있습니다. 저희 IOTA 재단은 독일 베를린이고요. 그리고 저희가 하고자 하는 건 저희가 개발하고 표준화를 하는 임무가 있고 IOTA 이외에도 다른 프로토콜이나 소프트웨어를 개발하고 있습니다. 그래서 저희는 베를린에 저희가 기점을 주면서 여기에서 이제 다른 기업들이나 아니면 정부나 또는 다른 다양한 스타트들이 와서 저희가 그리고자 하는 그런 미래의 비전을 꾸준히 이제 설고 하면서 이루고자 합니다.
Yes, so far we have more than 35 people, and we're actually hiring a lot. And we're pretty global. We have an office in Berlin, in Oslo, and we're setting up in Chicago. Next month we're flying to Chicago to open it. And we're also probably going to set one up in Asia. Right now I'm thinking about Shanghai, but if you guys convince me, I'll go to Seoul.
China's banning ICOs.
네. 일단 저희가 멤버들이 꽤 많습니다. 그래서 지금 한 35명 정도 되고요. 그리고 지금 오피스 같은 경우도 꽤 글로벌해서 벨린과 노르웨이 오슬로에도 오피스가 있고 곧 시카고에서도 저희가 오피스가 하나 열릴 예정입니다. 그리고 저희가 지금 아시아에도 오피스 열지 생각하고 있는데 지금 상해가 되지 싶습니다.
We also have some really good advice on board, like for example, Richard Soley, who's kind of sees a godfather of industrial Internet things, and we have Oliver Bussmann, who's the ex-CIO of SAP and UBS. And what we're doing with the foundation is we're getting all of these domain experts on board who are helping us on very specific topics and also our syndicate network. Because at the end of the day, we want global dominance, right?
네, 그리고 저희 자문위원분들이 굉장히 이제 유명하시고 뛰어나신 분들이 많은데 예를 들면 리처드 솔리 같은 경우는 이제 IoT에 대표라고 불리시는 분이시고 추가적으로 다른 분들도 계십니다. 네, 저희가 이분들 저희가 자문위원을 하는 건 두 가지가 있는데요. 일단은 그분들은 각각 분야의 전문가시기 때문에 저희에게 이제 실질적인 도움을 주실 수 있고 두 번째는 이제 네트워킹을 하는 데 있어서 이분들의 인맥을 밀리면 상당히 도움을 많이 됩니다.
So now comes a very interesting part. So why did we actually develop IOTA? So when it comes to it, the thing is obviously every device in the future is going to be connected. So in the latest is ubiquitous computing platform where machines start interacting with each other and start interacting with humans as well, offering new services. And our big vision with this machine economy is that machines really start trading with each other. So we give a machine a wallet and they become their own economic agent. And what's really, really interesting through this system now is that one machine that has an access resource, access capabilities, access whatever, is able to sell it to another machine on demand. And as such, you can really start building up completely new networks.
네, 그래서 저희가 IOTA를 개발하게 된 이유는 결국은 저희는 IoT와 함께 이제 기계 경제라는 이런 비전을 가지고 있기 때문입니다. 저희가 하고자 하는 것은 기계들이 서로가 거래를 하고 기계들한테 지갑을 줬을 때 이 기계들이 또 다른 이제 경제 활동을 하는 그런 주체가 된 걸 알고요. 그래서 기계들이 서로 사고 팔면서 완전히 새로운 형태의 네트워크가 형성된 것으로 저희는 미래를 그리고 있습니다.
So we always call this going towards small decentralization because today everything is based on the cloud. So all of those machines are supposed to connect to the cloud, and the cloud then acts as a central decision maker. And always the cloud is a single point of failure. And we have scalability issues, and as such the cloud must make any sensors in the things environment. What we have to achieve, or what we have to enable instead, is that we have those local decision makers. So machines interact with each other, they share data, they share resources, and through that we get this emergent intelligence. And with this system, we really want to enable real-time decision making with any system. And as such, we can really build smarter cities based on IOTA.
네, 일단 저희 기존에 저희가 가지고 있는 시스템은 이제 클라우드 기반 시스템들을 저희가 많이 가지고 있잖아요. 클라우드 기반 시스템의 문제점은 단위 취약점이라는 겁니다. 그리고 또 확장성이 있어도 문제가 많은데 저희는 그것이 아니라 이제 정말로 스마트한 탈 중앙화를 저희는 하고 싶고 이걸 통해서 저희는 이제 집단 지성을 저희가 바라는 것도 있고요. 그리고 실시간으로 저희가 계정을 꾸준히 내리는 그런 미래를 그리고 있습니다.
So this slide is really interesting because now any machine with a wallet can really buy any resource it needs on demand. As such, the machine is no longer limited to its hardware specification. And you, as an application developer, can really think beyond the machine itself. You can think that, hey, there's this tiny sensor, but the sensor is really able to acquire any computation on demand. As such, the sensor can really do machine learning and anything else without being limited by its hardware. And this is really going to be a completely new platform for developers and companies to build completely new applications.
네, 일단은 이거가 지금 여기 나와 있는 슬라이드는 이제 기계들이 이제 더 이상 하드웨어에 의존을 할 필요가 없습니다. 하드웨어 스펙 이게 무슨 말이냐면 예를 들어서 제가 기계를 이제 개발을 하거나 소프트웨어를 개발한다고 했을 때 특정 센서가 있으면 이 센서의 기존에 있는 하드웨어 스펙에 제가 스펙의 기준으로 제가 짜는 것이 아니라 이제 이 기계가 나중에 미래에 어떻게 변할지에 대해서 제가 생각을 짤 수 있습니다. 그래서 예를 들어서 센서로 시작을 하지만 센서가 필요에 따라서 자기가 머신러닝도 배울 수 있는 거고 이것은 개발자들이나 아니면 회사들에게 굉장히 큰 기회가 되지 않을까 싶습니다.
So obviously we are all about the real world. We don't care too much about all this speculation stuff that is happening because we are truly focused on gaining worldwide adoption with our protocol. And here's some use cases that I'm going to discuss.
네, 저희는 실생활에서 이제 적용되는 걸 보고 싶고 일단 투기 같은 그런 지점에서는 저는 그닥 관심이 없습니다. 저희가 원하는 것은 전 세계에 저희 기술이 대중화되는 걸 보고 싶습니다.
For example, one of the use cases that we do with Bosch is this tiny XCK sensor, and the sensor is able to have humidity, temperature, and can securely transmit that data to the cloud via IOTA. And more interesting than that is we can go beyond just data, and we can say that, hey, this sensor is able to buy machine learning on demand from the cloud. So you send a tiny micropayment in IOTA, you pay per computation cycle, or you can also pay for services on demand in the cloud.
네, 그래서 일단 도시 같은 경우는 IOTA가 이제 도시 XK에서 돌아간다고 했을 때 일반적으로는 여기서 이제 얼마나 습한지 온도에 관해서 이런 내용을 주고받고 할 겁니다. 하지만 저희가 이 데이터를 초월하는
Another interesting use case that we bring together for example, is the car pass. So basically, we're integrating IOTA into the car. You have to secure all the travel, so you know what happened at each point in time inside the car, and as such, you can no longer fake the data. And IOTA together with BitChain, it's much more simpler now to share this data with a mechanic and any other third party. And the vision of this is also now we can also give the car a wallet. And the car can start paying for all of these different services and parking, toll stations, and whatever.
네, 두 번째는 카르페스인데요. 카르페스는 지금 보시면 국석이랑 빅체인 DB 이너지가 세 개가 협조를 하는 겁니다. 이거 같은 경우는 차가 지금까지 어디를 도착하는가에 대해서 그런 데이터를 저희가 조작을 할 수 없고 이것을 검증할 수 있고요. 그리고 이 정확한 이 데이터를 예를 들어서 뭐 차 수리하시는 분에게 직접 공유를 할 수 있고 다른 삼자들에게 직접 공유를 할 수 있습니다. 또 차가 자기만의 지갑을 가지고 있을 거기 때문에 필요에 따라서 자기가 무슨 서비스를 생각하고 있을 때 그것을 다 직접 공유할 수 있습니다.
Another use case of energy is shared charge. So what we're doing right now is we're simulating how a car can drive from Oslo to Rome purely based on blockchain and IOTA-based EV charging stations. So basically, we give the car and the EV charging station a wallet, and they can start doing this economic transfer to each other. So per kilowatt that you're charging, you make a tiny micropayment. And the first IOTA-based EV charging station will probably go live in the Netherlands, I think in early mid-October. So you can start paying with IOTAs for EV charging.
네, 그리고 아까 이거 말했어요. 네, 일단 여기 같은 경우는 제가 노르웨이 오슬로에서 제가 이탈리아까지 어떻게 운전을 해서 올 수 있는가 그리고 그 전기차가 어떤 식으로 충전할 수 있는가 하는 겁니다. 네, 그래서 저희 충전소와 그리고 차가 각각 지갑을 가지게 된다면 이 상황에서 뭐 제가 1kW당 얼마를 IOTA로 제가 마이크로 페이먼트로 낼 수 있고요. 그리고 이거 같은 경우는 네덜란드에서 10월달 중순쯤에 아마도 시범적으로 시행이 되지 않을까 싶습니다.
I'll try to wrap it up a bit. So this is another interesting use cases of the air updates. So basically make it possible for large OEMs to securely update the software of their cars. So we use IOTA for this data integrity. So the car has end-to-end verifiability, it can verify the update that is going to be pushed.
네, 그다음 두 번째는 이제 OTA를 사용해서 업데이트를 하는 건데요. 일단 IOTA를 사용해서 저희가 데이터가 충분히 안전하다는 걸 제가 검증을 할 수 있기 때문에 이거를 통해서 이제 엔투엔드로 자동차가 업데이트를 할 수 있습니다.
And probably one of the first killer applications of IOTA is the data marketplace. So together with two of the largest corporates, or 2 dozen of the largest corporates in the world, we're building a data marketplace. So we make it possible for a sensor to sell data but also buy data. And this will actually be a public demonstration. So we're setting up a website where you can go to and you can start buying data directly from the sensors. And the IOTA is here for 2 things also. One for the data security, so that you know that this sensor is selling the data, and secondly for those micropayments, that you can pay per data packet that you're buying and selling.
네, 그리고 저희가 IOTA의 킬러 얘기 될 것으로 예상하는 거는 데이터 시장입니다. 이건 뭐냐면 저희가 지금 한 20개 되는 기업들과 함께 일을 하고 있는데요. 이것은 이제 센서에 관련된 데이터를 살 수도 있고 그리고 팔 수도 있는 그런 것입니다. 이거는 저희가 공개적으로 데모를 할 예정이고 여러분이 거기에 가셔서 직접적으로 데이터를 사실 수도 있고 IOTA가 여기에 필요한 이유는 첫 번째는 아까 말씀드린 것 같이 데이터 보안이고 그리고 두 번째는 마이크로페이먼트 이 두 가지의 역할을 IOTA가 하고 있습니다.
Another interesting use case where it's a touch pay is that you are able to pay per article that you're reading. And so what we're setting up here is with flash channels, so we're going to explain afterwards. It's that, for example, you see an article and you have to pay for this image. And you can also really well use IOTA for this because it's fast and there's no transaction fees. And this is also a live demo that you can try out probably I think next week.
네, 두 번째는 이런 기사들이 있을 때 저희가 이 기사에 예를 들어서 이미지가 있다고 하면 IOTA를 통해서 저희가 신속하고 그리고 수수료가 없는 마이크로 페이먼트를 저희가 할 수 있습니다. 그리고 이거 같은 경우는 아마도 다음 주에 시도해 보실 수 있습니다.
So yeah, so if you guys want to try the live demo of IOTA, you can go here. And basically what we're simulating is how we are issuing a command to this machine. And what the machine does, it sends back the current temperature, the gradient, and other data. Everything happens in real time on IOTA, so it's completely secure, and you have this data integrity and this data authenticity. And it all happens in a browser. So this is live.
네, 그래서 만약 취업 데모 보시다면 저기 웹사이트에 가셔서 저희가 기계에 명령을 주면 실시간으로 기계가 저희의 어떤 단어를 보니까 그걸 보실 수 있을 겁니다. 그래서 완전히 이제 안전하고요. 그리고 이게 다 실시간으로 직접 알고를 사용해서 일어나는 거니까 네, 한번 해보시기 바랍니다.
Some stuff that is probably going to happen soon, maybe next month. So I'll try to give you guys a proper timeline for this stuff very soon. So today or tomorrow we're going to announce the Flash network and Flash or the Flash channels. So what the Flash channels are is like those bidirectional payment channels in IOTA where you can necessarily do instant transactions between two parties. And the way this looks like is that the participants are always able to open a channel between each other, then do this transaction settlement between each other off panel. And once you want to go back online, do the settlement, you just simply attach the transaction to the channel and it's done. And this is instantaneous and super fast.
네, 그래서 일단은 저희가 로드맵에 대해서 말씀드리자면 오늘 내일 안에 저희가 플래시가 왼쪽에 나옵니다. 그래서 플래시는 쌍방향간의 채널을 이용한 뒤에 거의 바로 이제 트랜잭션을 주고 할 수 있는 건데요. 네, 그래서 이제 만약 오프라인에 다시 온라인에 나더라도 제가 기존에 연결되어 있는 상황에서는 거의 순간 기다리지 않고 공정 기다리지 않고 바로 주고받고 할 수 있습니다.
Is some similar to the Bright network?
Yes, but it's like a one version. And it's also arguably more secure. We're going to do a comparison with it. And it's another module which we're talking about. I know it's mass authenticated messaging. So this is probably one of the most interesting applications or modules of IOTA because what it is a secure, encrypted, and authenticated data stream. So now if you have a sensor, you can start inputting the data itself into the tank and only authorized parties can read it. And this is incredibly interesting for anything that is related to supply chain. So we do a lot of work in supply chain with some of the largest logistic companies in the world, where we're basically giving a secure audit trail of a package that's being transferred from origin to destination. And mass authenticated messaging is already running on this tiny sensor.
네, 비밀로 있었어요. 네, 두 번째는 이제 MAM인데요. 이거 같은 경우는 이제 저희가 확인되고 그리고 이제 안전한 그 데이터 스테이팅을 저희가 보낼 수 있는 그런 서비스들을 MAM이 제공을 합니다. 이렇게 됐어요. 네, 그래서 이거 같은 경우 특별히 물류 쪽에서 굉장히 관심이 많은데 이제 물류에서 물건을 보내는 그 시점부터 도착하는 거기까지 어떻게 데이터가 안전하게 보관이 되고 그리고 권한이 있는 사람들만 읽을 수 있는 그런 내용을 담고 있습니다.
Something else that is going on in October is private transactions. So now with our topic service that we're developing, we can really have secure and anonymous transactions with IOTA.
네, 그리고 마지막으로는 이게 private transaction이라고 저희가 이제 IOTA를 통해서 좀 익명과 그리고 사생활 그런 거래를 할 수 있습니다.
And another cool thing, because of what we complained about the wallet that IOTA makes. So thanks to UCL, we have some students who are now helping us out by developing a completely new GUI wallet. And the beauty of this wallet is that it really makes the user experience much better. So with this wallet, we're going to completely automate some of the processes, like for example reattaching. And it's going to be also very interesting when it comes to seed generation, and we have better transaction overview, and it's also going to work with iOS and Android.
네, 그리고 제가 만드는 그 지갑에 대해서 여러분이 좀 불평이 좀 많으셔가지고 저희가 UCL 학생들 몇 명이 저희가 이제 구이 지갑을 완전히 새로 만드는데 도움을 많이 줬습니다. 그래서 이런 건 사용자 경험이면 저는 과거에 비해서 훨씬 다르고요. 리얼 태칭이 아니면 시대를 생각하는 거 아니면 다양한 기능이 있어서 그런 것이 좋을 것 같아요.
So something else that's really important for us is really the ecosystem. So we're really we have a flourishing ecosystem where corporates, startups, and developers start working together and creating cool shit. And so what we set aside is more than $10 million, which are really there to push forward open source and also make it possible for people who are just getting started to have a financial incentive to contribute.
네, 그리고 저희가 하고자 하는 IOTA를 통해서 활발한 선택의 주선하는 그래서 스타트업이나 개발자들이나 아니면 기업들이나 다양한 사람들이 와서 IOTA에서 여러 가지를 이제 만드는 걸 저희가 도와드리고 싶어서 저희가 IOTA 이코시스템 펀드라고 따로 이제 1,000만 불 정도를 저희가 예치해놨습니다. 그래서 누구든지 오셔가지고 여기서 뭔가를 하고 싶으시다면 펀드를 통해서 자금 조달을 받으실 수 있습니다.
And last but not least, so as I promised, I want to get $10 for my IOTA. So if you go to this website, you can sign up with your phone. And what's going to happen then is you will get a secure seed. But you can sort of try it and tell me first. Alright, I don't want to be embarrassed.
네, 약속한 바로 제가 우리 IOTA 드리는데요. 지금 들어가셔서 했었으면 지금 한번 해보시고 안 되면 제가 되게 난감한 상황을 해보시고.
So just to know the way this works is that you get a seed and you have to save the seed. So tonight when the coordinator goes live again, we will send you 20 amount of those seeds and then you can start transferring to your wallet or just keep it.
네, 가셔서 시드를 받으시는 거예요. 오늘 저녁에 코디네이터가 다시 올라야 했는데 그 시점에는 이 20 IOTA를 여러분이 받으실 겁니다.
So yeah, that was the entire presentation so far. So I think we can close it with Q&A if you guys have any questions.
지금까지 하겠습니다.
Although your answer, I'm always curious about these questions because you are using cloud network, so I think you need some security solution for the end.
So we don't use in the cloud. We were really all about mesh networks, where those tiny devices are starting building up mesh networks. They really build up this peer-to-peer network. So we don't rely on the cloud.
So as I understand, your node broadcasting send transaction irregularly, randomly, right?
So you transfer, or you mean broadcast?
Yeah.
You broadcast into the entire network. It's not
Entire-
random.
Each one.
Yes, so it's a typical gossip protocol. So it's a gossip protocol. So if he has a transaction I have never seen, he will share it with me, and I will share it with all of my neighbors and all of my nodes. And as such, we have this peer-to-peer network where we constantly share those transactions.
한국말로 하겠습니다. 오늘 IOTA 와서 서비스를 좀 많이 설명을 드렸는데요. 메인이라는 거하고 그다음에 프라이버시 스트리밍 관련된 서비스를 여기서 처음 들었습니다. 그래서 더더욱이 걱정이 되는데 그 트랜잭션 피가 없다는 건 지금 상태에서는 가능하지만 IoT 상에서 전체 굉장히 많은 디바이스가 물려졌을 때 그 네트워크 상에서 부하가 분명히 걸릴 거고 그 부하는 분명히 통신사에 관심을 끌게 될 거고 아마 부가가 될 것 같은데 그런 상황에 대한 시나리오가 있는지 그런 걸 해소할 수 있는 그런 시나리오가 있어서 계속 트랜잭션 피가 없게 갈 수 있는 방안이 있는지 그게 좀 궁금합니다.
Okay, so the question about scalability. I came here for the first time here and private transactions and all this other stuff. But what also worries me is that as the bigger the network gets, wouldn't that attract attention from a lot of the internet service providers because there would be a lot of network usage, and at the same time, how would you keep the fee low?
So that is a problem in any blockchain. So any blockchain is really limited to their network. And what we are trying to set up, obviously, is we really want to encourage mesh networks to be built, so we no longer fully reliant on ISPs. But the thing is that the setup, any blockchain is really dependent on having a proper network infrastructure because the network propagation is really crucial, especially for IOTA. But you could set up a bunch of nanosatellites, set it in space in which to set up a relay network. Here's one of those crazy ideas. Just say that's a problem in anything.
네, 그거는 어떤 시스템이 다 문제죠?
I don't think so.
Now it's another problem we can't make because the problem is not just is that the blocks keep getting bigger, and as such, they have a much bigger problem with the network propagation because setting around a few megabytes of blocks is even bigger than just a few kilobytes of transactions. And as such,
No, I don't think that the question is related with that things because the question from the lady is also, I have a curiosity about the security problem. You said about the M2M, you mean the machine to machine, But at that time, I think the IOTA should have a kind of the security solution, something like RSA 1024 or something like that. Because between the machine, you could have any kind of risk to who got.
Do you need a trusted execution environment, stuff like that security on the machine itself? Yeah, IOTA comes out of a hardware startup, so we're building our own hardware.
Your own hardware.
Yeah, we're building our own hardware specifically for IOTA. And also
And then if you have that kind of hardware, and then in the IoT world, you cannot estimate how many transactions will be occurred in the future. So
exactly.
and
No,
then but you still want to have. I still want to have a kind of a contribution, some kind of by device network.
Yeah. If you want to build your own private network, where do you buy center? So one thing is really all about hardware security. And we're also really focused on building dedicated hashes and get IOTA integrated into all of those machines. So HSN modules, TEEs, and so on and so forth are really crucial for us and for any other blockchain out there.
I think it's no problem because it's a power on transaction is power.
Yeah, exactly. And we developed an economic cluster which really further drives this vision of having a bunch of mesh networks that connect with each other, and we have those clusters in this high throughput environment, so you can have your own network, but also you're still connected to the local peer-to-peer network. And you can think of it similarly to sharding, just based on IOTA.
Then I have one question, and simply there are some cache content, some problem, so that is there a problem? Is there a schedule to the hard fork or the soft fork in IOTA?
No, there was no security component at all. So there's no big vulnerability that could have led to losses of people. So what we developed is our own ternary hash function because we're building ternary hardware. So it's not based on binary, but it's based on ternary, so 3 states. But we're still continuing to develop the hash function. We've just recently hired 5 cryptographers to help us build this hash function because for either of the things, you need to have a new hash function, which is really lightweight. It doesn't use too much energy, and it's still an integral part of IOTA. Because you can't use the pickers and stuff like that.
So that application is not needed the soft fork.
Sorry, it's not
It
needed.
is not needed soft fork and source code and the source code.
It means
Restoration? When
Sorry.
there are some problems?
Sorry, my
you mean if there was a problem that
So I think it's asking is there a necessity for forking?
you can't fork IOTA. You can't fork IOTA. But we did is we did a safety precaution. We did a precautionary measure just to upgrade the network, and while we're right now further developing its peer review kernel, then we're going to integrate it back into IOTA. So it was a safety measure.
And can I ask you about policy of German? Can I ask? Because machine-to-machine transaction, there need so many social infrastructure technology,
Yeah.
AI, and cloud, and big data, IoT like that. So in German, how does on the open data use?
So Germany has really good data privacy laws. And the big vision of IOTA is that you are your owner of your data. And so it's really you start moving away from just being a consumer. So you buy a good, and the data is generated is owned by a company, versus a prosumer. So you can decide what you're going to do with the data that you get. So for example, what we're setting up in Norway, we are setting up this health cluster. So we have a partnership with the Norwegian government where we're making it possible for you to share your healthcare data across border with IOTA.
I think my second question is that you mentioned the flash network. It is needed some fork to apply the flash network.
No. So we start going tomorrow. So the beauty of IOTA is that the base layer is very, very simple, and you can start building modules on top.
Also.
Exactly.
Just add it.
Yeah, so you don't need a hardware or protocol object for each one. We're already using it just so long.
Yeah, I'm studying IOTA nowadays, and it was not difficult to find information about the single network itself, but I had a hard time to find some information about the node, IOTA node. So basically, I have three questions. The first one is, who can run a node? And the second one is, what is the incentive to run a node? And third one is, how the nodes maintain their consistency between each other.
Yeah. So the first question, right now we have a reference implementation of IOTA, which is written in Java. So you have Java install, and you run 4 gigabytes of RAM. And then you can start running your own node. But then, of course, you have to search for neighbors in IOTA, because we don't use security discovery for security reasons. So you have fun neighbors who then give you the ability to participate in the security network. So then you're a full node. The second question,
What is the incentive to run a node?
There's no incentive. There's no incentive to run a full node in Bitcoin or in Ethereum. The really good thing about IOTA is that the validation required for running a full node is much lower compared to Ethereum or Bitcoin, because you don't have this transaction ordering. As such, it's much cheaper to run an IOTA full node. Third question.
Third one
I
is
forget
how to maintain the consistency between
of course. So it's really dependent on the Dominik protocol, making sure that the network propagation across the entire network is solid and works. So through that you have this consistency.
This is my last question. I think IOTA is very core technology to me, software engineer. So that I wonder what is your computer and your no, sorry. Your most big computer.
So the biggest competitor,
Yeah.
maximalist. So yeah, because the big problem about blockchain is that everyone has a financial incentive to say that their blockchain, their cryptocurrency is the best. And they are willing to go above and beyond just to push their agenda. And so that's why you have a lot of FUD attacks where they just say a bunch of lies about you. That's probably the biggest competitor. But apart from that, we have no competitor right now. We're the ones that introduced DApps to the space, and we're the ones that first successfully built a DApp. So there's some other ones which are being developed right now, but we're studying the kind of research.
But I think that Ethereum is the most computer.
Ethereum, I don't think Ethereum is a competitor, because we're really focused on transactions. We're going to focus on smart contracts. We could actually work together with Ethereum if we enable this interoperability.
저기 한국 질문 좀 통역 좀 해주세요. 이 디바이스 M2M 머신 투 머신에서 디바이스의 레벨을 어디까지 고려하시냐, 즉 그 머신 투 머신에 아까 기계들끼리 핑을 좀 한다고 했는데 지금 센서들 중에는 뭐 지금 현재 다양한 아두이노니 뭐 인텔, 에디슨이 갈릴레오가 하는 것들도 퍼포먼스 문제가 있는데 아이오타를 적용하기 그게 어디까지? 그러니까 예전 머신들, 예전 디바이스들에 있는 칩들도 인터프리터가 이해할 수 있는 정도의 수준이냐, 퍼포먼스가 나오냐 이게 조금 궁금하거든요.
My question is about how much do you take into consideration IOTA is mainly for machine so how much do you take into consideration of some of the older machines, like the levels they consider. So if for example if you take for example sensors, so some of the older sensors, like how are they at interpreting it or interpreting IOTA or how's their performance?
Right, so the main assumption is obviously connectivity. If you don't have connectivity, the machine can't be full node. But the beauty of IOTA is that you can start decoupling some of the processes involved in making a transaction, and you can make it possible for all the machines to install some of those modules. Like for example, an older machine could really well just install mass authenticated messaging, and as such is able to secure and encrypt data that it's connecting. And then it also needs to have the ability to interact with the full node, and as such this sensor is now connected indirectly to this peer-to-peer network. So there you also different line clients and full clients, and also all of those modules which we are developing are really focused on IoT.
But based on your explanation, I think the device and or sensor should have a kind of a memory to contain, the address of wallet and then
All you need is the ability to sign. So all
you just send, 0 or 1,
yes, so you
do or not, or something kind of.
So what these sensors would do is they would just build a raw transaction. So they just hash the data. They say like, hey, I'm going to sign this transaction with my private key. And as such, I'm going to send 10 IOTAs to this other machine. Then what this machine is going to do is going to transfer this raw transaction to the other machine or to a full node. And the full node is then going to do the hard work. It's going to do the transaction, the confirmation, and the proof of work. So it's the thing about it is that this is a very hierarchical system. And we were really able to mimic this really well. This hierarchical system. So your coffee machine is not going to be a full node. Your coffee machine can have a private key, and with a private key, it has a lock.
Thank you for your presentation. I'm sure there are a lot of applications for IOTA. Let's imagine now I have my idea, my use case that is ready. I have all the hardware, all the chips, and I would like to connect some, let's say 1 million nodes to the IOTA network. When would I be able to do that?
So right now, IOTA, Bitcoin, Ethereum, everything is a proof of concept. So nothing is production right now. And our vision, especially thanks to the IOTA Foundation, thanks to our launch corporate network, is to make IOTA production ready by end of 2018. So there's a great vision, so then we're also going to enable economic clustering. And it's kind of an ambitious goal, but we'll see how it goes. You know Hofstede's law. So, and Murphy, software development is difficult. And when it comes to the hardware, so the thing about our vision is really also hardware. So you need to be able to secure the data on the machine itself. You need to have this trusted execution environment to connect the data and send support. And that's kind of the main difficulty here also to figure out how to put those pieces together.
Will IOTA be used for autonomous driving vehicle in the future?
Yes.
Yes. And furthermore, I have a question.
I mean, autonomous vehicles are really part of our mission with IOTA because at the end of the day, you want to have this autonomous, you don't just want autonomous vehicles, you want autonomous economic agents. So that they also can start participating in this economy, they can start paying other machines, other persons, and so forth. Yeah.
In the future, if we use contact communication in autonomous driving vehicles, I think as you know. And as you know, contact communications cannot be hacked, so it is suitable for autonomous driving.
Can we hack contact?
Hack?
I mean, B2B communication can be hacked. Autonomous vehicles can be hacked. Yes, so one of the very interesting things that we're starting to think about with IOTA is how we can secure, how we can make IOTA an enabler for system integrity. It's not just about data integrity, but we start building consensus inside the vehicle itself for this system integrity. But it is kind of a bit further away, but IOTA would make a lot of sense to have this consistency and this consensus between the ECUs inside the vehicle. As such, you can start really preventing attacks from outside or also from inside. But the security of things is really an integral part of our vision.
So what you just said before about having internal consensus, for example, a car, that would that also be treated as kind of a side thing of a mechanism and everything?
Yeah. So yeah, and your questions also can work with up and versus food. I'm also kind of hungry.
The wallet that you were showing the slide, you said that's going to be released in October. All the stuff that's going to be released.
Yeah, so all of the Zoom stuff that Mr. Schiener mentioned here is released in October. Don't blame if it's not released in October. I'll be working on it.
This is not really technical, but from the place you travel, any place that.
So yeah,
it's very hard to implement smart contracts into IOTA itself. So, do you have any plans to build a platform on top of IOTA that will implement?
So it could be a layer 2 solution, and you're also enabling timestamps in IOTA. And once those timestamps are enforced, you could do smart contracts.
Yeah, but the whole network is asynchronous.
Every network is asynchronous in IOTA. So we were able to really achieve this consistency and this transaction serialization ordering in IOTA with the timestamps as well. If you write our white paper minutes, so we write the estimate and the timestamps will probably also enforced or made available in the store.
I think a lot of people and also fraudsters are saying what the difference is between the lightning network and the fast network. Could you briefly explain what the difference is?
So one thing to emphasize is that we know the network, so it's really bidirectional payment channels right now, so one party with another party. And the major advantage of IOTA versus the lightning network is that there's no transaction fees. So we can open a channel, we don't pay any fee. We can close a channel, we don't pay any fee. And in Bitcoin and in Ethereum, we still have transaction fees. As such, they are able to work these machine contracts. But today we're writing a very technical blog post which makes it a comparison. Alright, perfect. So thanks a lot everyone for listening and asking questions. By the way, quick question. Did you work with the seed stuff?
Yes.
Cool. Alright, thank you.